In this video, I am going to be discussing graphs of polynomial functions. So we'll be talking about how to graph these given a function. We'll be talking about how to write an equation or a function given a graph, and several things related to that. This information corresponds to the free online textbook from openstacks.org. It's the college algebra textbook, and it corresponds to 5.3, the section there. You will see the website on the presentation as I go through. So if you want to go and get more information, please pause the video when I'm scrolling over the website and you'll be able to get there from that. So the first thing we want to do is find x-intercepts of a polynomial function. This is something that was discussed in the previous section, but I just want to review it again to make sure we remember how to do it, and because I'm going to tie it into something else that we're going to talk about in this section. So to find the x-intercepts, remember that you're letting y be 0. So this means let y be 0 and then solve. So 3x plus 2 times x minus 3 times x plus 7 equals 0. This is already factored for us, which is the best case scenario. Now we just let each factor equal to 0, and then we solve. This 3 does not have a variable there, so that will not lead us to any kind of solution. X plus 2 equals 0. If we subtract 2 from both sides, we will get x equals negative 2. So there's going to be one x-intercept. X minus 3 equals 0. We're going to add 3 to both sides. We're going to get x equals 3. And then x plus 7 equals 0. We're going to subtract 7 from both sides. We get x equals negative 7. So those are going to be our 3 x-intercepts, and we need to write them in an ordered pair form because that's what an intercept is. So we're going to have negative 2, 0, 3, 0, and negative 7, 0. So here we will have 3 x-intercepts that are listed there. All right, number 2, find the x-intercepts. Here, this is not factored for us, so we need to factor it. So we're going to set it equal to 0. That's the first step. And then we're going to try to factor this. So the first thing we can do is factor out a common factor. So 4 will factor out of all of those evenly. They also have an x squared in common. So I'm going to divide out 4x squared and then see what's left. So for the first term, that will leave me x squared plus 3x for the next term, and then minus 10 for the last term equals 0. Remember, as a reminder, what we're doing here is we're factoring out, which means dividing out the greatest common factor from every term, and then writing what's left over in the parentheses. Now we want to try to continue factoring what's in parentheses. So 4x squared comes down. The x squared will break up into x and x. And then we want to find out what multiplies to get negative 10 and adds to get 3. So if we use a positive 5 and a negative 2, that multiplies to get negative 10 and adds to get positive 3. So now this is factored. We're going to go ahead and solve each one. So 4x squared equals 0. I can divide by 4. That will give me x squared equals 0. And if I take the square root of both sides, I can put plus or minus, but it won't make a difference because it's 0. So x equals 0 is the one solution here. Then we have x plus 5 equals 0. We're going to subtract 5 from both sides. We get x equals negative 5. And then x minus 2 equals 0. We're going to add 2 to both sides. We get x equals 2. Okay, so now we have our intercepts. So our x-intercepts are 0, 0, negative 5, 0, and 2, 0. Okay, number 3, same thing here. We want to find the intercepts, the x-intercepts. Notice here we have 4 terms. I'm doing this one just to remind you how to do this factoring technique. So here, remember you want to do factor by grouping. So the common factor in the first pair is x squared. When I divide that out, I get 2x minus 1. Bring down the negative. What's in common here is a 4, so you're going to be dividing by a negative 4. So if you divide by a negative 4, that'll give you a positive 2x minus 1 equals 0. Now 2x minus 1 is your common factor, and the leftovers are x squared minus 4. You can factor the x squared minus 4 again because that's a difference of squares. That'll be x plus 2 and x minus 2. And then you set each factor equal to 0 and solve. All right, so when I solve this first one, I'm going to add 1 and then divide by 2. So x equals 1/2. The next one I'm going to subtract 2. So I'll get x equals negative 2. And then the last one I'm going to add 2. So x equals 2. So my 3 x-intercepts are 1/2, 0, negative 2, 0, and 2, 0. Okay, so let's look at that and then compare it to the next part. So the number of times a given factor appears in the factored form of the equation of a polynomial is called the multiplicity. So if you have a factor that appears more than once, it will be a multiple factor, right? It's happening more than one time, so it's a multiplicity. The multiplicity of a factor determines how the graph will act at the x-axis. So if we look at these examples, if you have a single 0, which means you have something like x to the first, so the exponent is a 1, so really it's just x, right? It crosses directly through the x-axis. It just goes right through it. If you have a 0 with multiplicity 2, like let's say x squared, so the exponent is a 2, it bounces off the x-axis, just like it would if it was a quadratic, right? It looks like a parabola. If you have a 0 with multiplicity 3, so a factor with an exponent of 3, then it looks like a cube, right? It wiggles. So it changes direction, goes up and wiggles and keeps going up. So let's look at some of these. Find the zeros and give the multiplicity of each. So the first thing we need to realize is if it says find the zeros, this is the same thing as x-intercepts. The zeros, however, just refer to the value that you get for the x, okay? Because you know that the y is 0. So when it says find the zeros, you just have to give the x value. If it says find the x-intercepts, you're going to give it in an ordered pair form. But you're doing the same thing to find the answers. The multiplicity is asking what the exponent is on each of the factors. So that being said, let's look at number 4. Notice that number 4 is already completely factored out. So we're going to have zeros, which means find x-intercepts. So we're going to set it equal to 0, and then we're going to solve. Since it's already factored, I can set each factor equal to 0. Let me go ahead and write the 5th here, and then we'll talk about that. Equal to 0 and solve. So keep in mind that I can write the factor with the exponent, but what am I going to do? Let's look at the second one. Well, it doesn't matter, the first one. What am I going to do to undo the exponent? I get rid of the square by taking a square root. But the square root of 0 is simply 0. So I could have just written x equals 0. For the second one, to get rid of the fifth power, I have to take the fifth root. But any root of 0 is simply 0. So really, you only need to write down the single factor without the exponent equal to 0 and solve that. That's what you're looking for, because you're going to undo the exponent anyway and get down to the linear factor. Okay, and so now you just need to solve these. So subtract 3 from both sides. You get 2x equals negative 3. Divide by 2. So x equals negative 3 halves. And then the last one, add 4 to both sides. So x equals 4. Okay, so here are your zeros. 0, negative 3 halves, and 4. Those are your zeros. So at each 0, there's a multiplicity. So I guess we can make a chart. The zeros and the zeros multiplicity. Okay, so the first 0 we found was 0. The next 0 we found was negative 3 halves. And the last 0 was 4. The multiplicity is going to come from the exponent associated with the factor for that 0. So if we look right here, this all goes together. A 0 of 0, its exponent was 2. So its multiplicity is going to be 2. When I look at the next factor, there's all the work that goes with that. The 0 is negative 3 halves. The exponent is 5. So its multiplicity is 5. And then finally, I have the last factor. There's all the work that goes with it. The 0 is 4. The exponent is 2. So the multiplicity is 2. So finding the zeros is the same thing as finding the x-intercepts. It's just in this case, you don't have to write it as an ordered pair. You could just write the x values, right? And then the multiplicity, again, is the exponent on that factor. Okay, so let's look at number 5. This one is going to be the same thing. However, we need to factor it because it's not factored for us. So that's going to be the first thing we do. We're going to set it equal to 0 and then factor. So there's not a number in common for all of these, but they do all have an x cubed. So I can factor out an x cubed. That will leave me 4x squared minus 12x plus 9 equals 0. Now I can try to factor that again. So it'll be 4x squared. I need to figure out what multiplies to give me 4 times 9, 36, and what adds to give me the middle number, negative 12. So let's see if we can figure out something that would work. So 6 and 6, right? But they both have to be negative. So negative 6 times negative 6 is positive 36. And negative 6 plus negative 6 is negative 12. So what I'm going to do here is split up the middle term. This negative 12x is going to split up into negative 6x and negative 6x. Bring down the 4x squared and the 9. And now I can factor by grouping here. So I just need to remember to bring this down at the end. For now, I'm going to leave it off. So, and just focus on what's in parentheses. So what's in common with the first pair is 2x. When I factor that out, I have 2x minus 3 left. Bring down the negative. Now what's in common is the 3. If I factor out a negative 3, I will get a positive 2x minus 3. Okay, and so now I have 2x minus 3 in common. And this 2x minus 3 left over equals 0. Bring down the x cubed. Okay, and so now if I see that I have the same factor repeated, this 2x minus 3, I can write it as 2x minus 3 squared equals 0. So now I have it fully factored. You can see that I have two different factors. I have two unique factors. My first factor is x, and my second factor is 2x minus 3. So to find the x-intercepts, or the zeros, I'm going to set each of those factors, ignoring the exponent, equal to 0, and solve. So x equals 0 is 1, and then I'm going to add 3 to both sides, divide by 2, so my other 0 is 3/2. Okay, so my zeros are 0 and 3/2. And then the exponents on those are going to be the multiplicities. So the exponent on 0 is a 3, so the multiplicity 3. The exponent on the 3/2 is 2, so it has a multiplicity of 2. Okay, so really this goes back to finding the x-intercepts. It's the same work, it's the same process. It's just now they're called zeros, and you're having to look at the exponent on the factor to find the multiplicity. Okay, so a reminder, a polynomial of degree n will have at most n minus 1 turning points. This is telling you how to sketch a graph of a polynomial function. The first thing you're going to do is find the intercepts. You can do number 2, the check for the symmetry. That will help you kind of see how it looks and possibly mirror some points. I usually skip that one and look at number 3, use multiplicities of zeros to determine the behavior of the polynomial at x-intercepts. Determine the end behavior, use the end behavior and the behavior at the intercepts to sketch a graph, and then ensure the number of turning points does not exceed 1 less than the degree of the polynomial. Okay, so let's do that. So first, let us find the intercepts. So x-intercepts, we're going to let y be 0. Remember, this is the same process as finding the zeros. So we're going to have both of those done when we do this. So we have x plus 4 squared times x minus 1 squared equals 0. This is already factored for us. So x plus 4 equals 0, x minus 1 equals 0. So we'll have minus 4. We're going to add 1 in this case. So we're going to get x equals negative 4 and x equals 1. Okay, so for the x-intercepts, you have to list those as ordered pairs. We have negative 4, 0 and 1, 0. There are the x-intercepts. Now remember that this also gives us the zeros. So the zeros, let me do it up here. Zeros and multiplicities. Zero of negative 4 and a 0 of 1. The 0 of negative 4 has a multiplicity of 2, and the 0 of 1 has a multiplicity of 2. Okay, now I need to find the y-intercept. That's when I let x equal 0. So we'll have y equals 0 plus 4 squared times 0 minus 1 squared. That's going to be 4 squared times negative 1 squared, 16 times 1, which is just 16. So the y-intercept is 0, 16. Okay, so we found the x and y-intercepts. Let's go back up to our list here. We found the x and y-intercepts. We found the multiplicities and the zeros. So we'll figure out how that works with the graph. We need to determine the end behavior by looking at the leading term, and then we can sketch our graph. So let's look at our leading term. So the leading term, when it's factored like this, the easiest thing to do is look at the leading term in each factor and use the exponent and multiply those together. So the leading term in the first factor is x, and it's an x squared, times the leading term in the next factor is x, and it's an x squared. This will be 4x to the fourth if I multiply those together. That's going to be our leading term. So rather than multiplying it all out, the only thing you need to look at is the leading term in each factor. Multiply those together. That will give you the leading term overall. So here's my leading term. And if you remember from the previous section, this tells us the end behavior. So we have a positive and we have an even exponent. So remember that a positive even, the ends are going to both be pointing up. So that's something to keep in mind as we draw our graph. Okay, the first thing I do when I am graphing something like this is I put the intercepts on the graph if they fit. So the y-intercept is not going to fit. It's going to be way up here. We can just, I guess, pretend. So let's say 16 is up here. Okay, so there's the y-intercept. The x-intercepts are -4, 0, and 1, 0. Okay, so now that I have my x-intercepts on there, I can see the furthest right and I can see the furthest left. So I'm going to then use that and use my end behavior to draw the arrows. Okay, so this is going to go this way somehow, and this is going to go this way somehow. They both have to be going up. Okay, and this is a sketch, so that's fine if that's what your arrows look like. You might decide to make your arrows go out further like this. Great, okay? This is a sketch. You might make your arrows go up further like this. Great. As long as they're facing up and you're going through the correct x-intercepts, that's really what we're looking for, because again, this is a sketch. So there's the end behavior. Now what we want to do is look at how it behaves according to the zeros. So remember that a 0 of 2, that's what I have here, a 0 of 2, it bounces on the x-axis. So it's going to do like this, right? It's going to bounce off the x-axis. And that's the same thing for the next one. The 0 of 1 also has a multiplicity of 2. It's an even multiplicity, so it's going to bounce off the x-axis. So that means at these, I need to go down here and it's going to bounce back. So I just went down and bounced back up, okay? Now, obviously, I'm going to have to go all the way up to this 16, and then I've got to come back down because I've got a point on the x-axis. So I'm going to turn and come down. At the 1, it has multiplicity 2, so I'm going to bounce back up as well. So I do not go through the x-axis. I bounce at that point, and that's because the multiplicity is 2. And so there is a sketch of the graph. All right. There's a lot of information that goes into graphing these. So remember, first thing we want to do is find the x-intercepts. So we let y be 0. That will be -3x times x plus 2 times x minus 4 equals 0. This is factored for us, so I'm going to set each factor equal to 0 and then solve. So divide by -3. We get x equals 0. I have x plus 2 equals 0. So subtract 2 from each side. I get x equals -2. And then x minus 4 equals 0. Add 4 to each side. So I get x equals 4. Okay, so the x-intercepts are 0, 0, -2, 0, and 4, 0. those correspond to zeros, right? And they have multiplicities. So 0, 0. I guess I can make a chart again. So zeros, multiplicities, okay, so my zeros are 0, -2, and 4. And then my multiplicities associated with those, there are no exponents on any of my factors. If I look at my original equation, my original polynomial, no exponents. So all the multiplicities are just 1. Remember that this means the graph is going to go directly through the x-axis. No bounce, no wiggle, just goes straight through it. Okay, and so now I've found my zeros, my multiplicities, my x-intercepts. I need to find my y-intercept. So x will be 0. So y equals -3 times 0 times 0 plus 2 times 0 minus 4. And since I'm multiplying by 0, it's going to be 0 all the way across. So my y-intercept is 0, 0. I now need to look at the end behavior. And so I need to multiply the highest or leading term of each factor per se. So I have this -3x squared. So you always multiply by the thing out front. Then I have an x, no exponent, which is a 1, and x, no exponent, which is a 1. So I'm multiplying those together. So -3x times x will give me -3x cubed. So that is my leading term. So this is a negative and an odd. So this is going to be up on the left and down on the right. So that's the end behavior. So now what I want to do is graph my x-intercepts. So 0, 0, -2, 0, 4, 0. My y-intercept is already on there as well. I want to look at my end behavior and my multiplicities. So from all the multiplicities are 1, I know it's just going to go straight through the x-axis. And the end behavior, it needs to be going up on the left and down on the right. So it's going to look something like this. It's going to go straight through the x-axis. But then I've got to come back and get this next point on the x-axis. So I've got to turn at some point. I'm going to turn and come back up. Now again, I've got to turn at some point to go back to the 4. So I'm going to turn and go back down. And again, it goes straight through the x-axis at each of those points. So again, this is a sketch. I chose to turn at those points because that's what felt good to me. Another acceptable graph that I will do in blue, because it's a sketch, yours might look like this. Okay, maybe you did something weird like that. It doesn't matter, it's a sketch. As long as you have the end behavior correct and the x-intercepts and the y-intercept correct and the multiplicities correct, you know, the way it functions at the x-axis, that's fantastic. That's what you need to know at this point. Whoops, okay. All right, so number 8. This now we're going to be given the graph and we want to write the formula. So we're going to be kind of doing it backwards. So for this, I'm going to be trying to find the zeros or the x-intercepts. So I can see those from here, right? Okay, so the x-intercepts are -3, 0, -2, 0, 3, 0, and 4, 0. So the zeros are -3, -2, 3, and 4. Now each 0 comes from solving a factor, right? So if I know that the 0 is negative 3, that means the factor associated with that is x plus 3. Because when I solve x plus 3 equals 0, I get negative 3. The factor and the 0 always have opposite signs. So the factor associated with a 0 of negative 2 is x plus 2. The factor associated with a positive 3 is x minus 3. And the factor associated with a positive 4 is x minus 4. So those are the factors I'm going to be dealing with in my polynomial. Okay? So now what I want to look at is end behavior. So my end behavior, notice both ends are going down. So that means it's going to be a negative even. So a negative even is what I'm looking at because both ends are going down. So I have my x-intercepts. I have my end behavior, so I know that I'm going to be expecting a negative coefficient and I'm going to be expecting an overall even power. I need to find one other point besides an x-intercept to use. I can see that this y-intercept could be useful. That's a point I can tell what it is. So the y-intercept is 0, negative 3. So that's an x and a y value. What I want to do now is I want to set up a function and I'm going to use my factors and then realize that I might have some multiple happening here, some a value, which you could see this in a previous section. So how you want to set it up? F of x equals a, so some factor, some multiple, times all of your factors that you know from your zeros. X plus 3, x plus 2, x minus 3, and x minus 4. So there's all my factors. You want to look at the multiplicity as well. So if I look at what's happening at the x-axis, notice that here at the negative 3, it's just going straight through. So that's a multiplicity of 1. At the negative 2, it's also going straight through. So that's a multiplicity of 1. And the same is true at the other factors as well. So they're all going to have multiplicity of 1. The a you always need to include in front. Then you need to use your other point that you can determine from the graph. In this case, I used the y-intercept to plug in for x and y. So here f of x is the same thing as y. Once you have your function written down with x's and the y, you're going to use your other point to plug in for x and y and then solve for a. So y is negative 3 equals a, which is what you're going to find. 0 is x. So everywhere I see an x, I'm going to plug in a 0. And this will allow me to solve for a. So I have negative 3 is equal to a times 3 times 2 times negative 3 times negative 4. So this is going to be 6 times 12, which is 72. So negative 3 is equal to 72a. And then to solve for a, you're going to divide by 72. So you get a equals negative 3 over 72 will reduce to negative 1 over 24. So your a is negative 1 over 24. So once you solve for a, you're going to leave the y and the x's as variables, and then you're just going to use the a value. So we're going to use the a value, and you're going to use all your factors, and you're going to write your polynomial. So the y you're going to write as f of x is equal to a, which is now 1 over 24, negative 1 over 24, times x plus 3, times x plus 2, times x minus 3, times x minus 4. Okay? Now, I am fine with you leaving it like this. However, A lot of times you're going to be asked to distribute this all out, multiply it all out, and then give your polynomial. That really is what you should do technically, although at this point in the class, I expect that you know how to distribute. So I'm going to be okay with you leaving it like this, but you really should distribute it all the way out and get your polynomial, okay? You probably will have to do that for your Edfinity assignments, so make sure you do that all the way out. But this is it. This is your polynomial function. Okay, so let's look at, and let's just verify the end behavior. So it is a negative, which we expected from the end behavior. And notice we have 4 factors, so that's going to be an exponent of 4, which is even, which is also something that we expected. Okay. All right, number 9. So again, we're going to find our x-intercepts, which are our zeros. So we have a 0 here. A 0 of -2 is going to be associated with a factor of x plus 2. And notice here how it goes up to the x-axis and then bounces back. It does not go completely through the x-axis. That is an indication of an even multiplicity. And so we're going to say that's multiplicity 2. It could be another multiplicity that's even, but since we're finding the least possible degree, we use the smallest even, so 2. And then our other 0 is at 3. The factor associated with that is x minus 3. And notice it goes straight through the x-axis. So that is a multiplicity of 1. Okay? So we're going to try to write our function. We have y equals a times x plus 2 squared and x minus 3 to the first. Now in order to proceed, I need to solve for a. I have to have another ordered pair. So here I can see this point is 0, -3, so that's the y-intercept. I'm going to use it. So I'm going to plug that in for x and y. So I will have -3 is equal to a times 0 plus 2 squared times 0 minus 3. So that's going to be -3 equals a times 2 squared times -3. So -3 equals 2 squared is 4, and 4 times -3 is -12. So it'll be -12a. Divide by, let's see, -12. So we will get a equals, the 2 negatives make a positive, and that will reduce to 1/4. So a is 1/4. So now to write my function, to write my polynomial, I have a to the 1/4, and I'm going to use my factors and their multiplicities. So I'm going to have f of x equals 1/4 times x plus 2 squared times x minus 3. And that is what I'm going to have here. Now notice I have a positive coefficient, and the end behavior matches that. And notice that I have multiplicity 3. To find your multiplicity overall, you can just add your multiplicities. So 2 plus 1 is 3. That's odd. The end behavior matches that as well. Number 10, use the given information about the polynomial graph to write the equation. So this is basically, if you had a graph, someone has already picked all the important information from the graph and given it to you, you're going to do what we did for the graphs. You're going to do the same thing. So we have f of x equals, or let me just go ahead and write y equals. I know that's what I'm going to want. Y equals a times, I have a 0 at x equals -2. Remember, the factor associated with that is x plus 2. The factor associated with 1 would be x minus 1, and the factor associated with 3 would be x minus 3. So it's always the opposite sign in the factor versus the 0. So x plus 2, x minus 1, and x minus 3. And then we're going to use the y-intercept to plug in the y and the x value. So we're going to have y is negative 4 equals a times x is 0. And then I'm going to simplify. So negative 4 equals a times 2 times negative 1 times negative 3. When I multiply all that out, I get positive 6, right? So 6a. Divide by 6. That's going to be a equals negative. When I reduce, I get 2/3. All right, so I'm going to have f of x equals negative 2/3 x plus 2, x minus 1, and x minus 3. And again, to find the polynomial, you should multiply it all out and get your solution. Okay, get your polynomial. Number 11. So this is the last one. We're going to have y equals a times, all right, roots of multiplicity 2 at x equals 3. So x equals 3, the factor is going to be x minus 3. And remember, the multiplicity is the exponent. So it's going to be x minus 3 squared. The factor associated with a 0 of 1 is x minus 1, so that's going to be x minus 1. And the exponent on that is 2 as well, because it says the multiplicity is 2. And then a root of multiplicity 1 at x equals negative 3. So that'll be x plus 3 with an exponent of 1. Now I'm going to use my 0 and 9 to plug in for x and y. So x, y. So 9 equals a times x is 0. So 0 minus 3 squared, 0 minus 1 squared, 0 plus 3. So it's going to be 9 equals a times negative 3 squared times negative 1 squared times 3. So negative 3 squared is 9. Negative 1 squared is 1 times 3. So that's going to be 27. So divide by 27. So a is equal to, when you reduce, you'll get 1/3. So our function is 1/3 x minus 3 squared, x minus 1 squared, x plus 3.